So first, we'll talk about how to get data in using our new Universal REST API fetcher. So it's not going to be only about cloud applications, basically any application, any data source that you can query using a REST API. First, we'll talk about how it works, and then the theory, and then we'll go over configuration examples to get a bit more practical. And once we've got data in the SIEM, we'll also see how to normalize it using another new application that we released a few days ago called the Universal Normalizer. And once again, we'll see the theory and we'll get more practical with some configuration examples. For questions, I will take some time at the end of the breakout session. So yeah, you will be able to ask your question during that dedicated time. So, getting data in using the Universal REST API fetcher. The Universal REST API fetcher is available since Logpoint 7.1 from last summer. Basically, when you want to get data from cloud application on any kind of data source requiring REST API queries, Logpoint does provide out-of-the-box connectors for some data sources like Microsoft 365, AWS, Salesforce, etc. And before July 2022, we didn't have a generic way, a flexible way of configuring these kind of data sources. So this is why the Universal REST API fetcher is here now. So it's a way for you to get any kind of logs, any kind of data from REST API endpoints, basically. So some links to the plugin itself and the documentation. I think you will receive the slides afterwards, so it's going to be easy to download it and actually use it. So how does it work? Basically, you have two different concepts in the REST API fetcher. You have a source, so basically a source is, it can be like the URL to your application. And once you've defined a source, you will be able to define different endpoints, at least one endpoint, which will be the path with the exact action to get the data you want. So depending on the data source, you can get like logs or alerts or any kind of data. Of course, the configuration will be really specific to each data source, tailored to each data source. So once you've installed the Universal REST API fetcher, actually it's already out of the box in 7.1, so you don't have to download anything or to install it. You have access to its configuration from the configuration menu. And instead of showing you screenshots, I will go over what's possible to do through a quick demonstration. So here I'm on a demo SIEM instance. I'm in the configuration menu and Universal REST API. So of course here I have nothing pre-configured. So I will add a new source. So you can give it a name, of course, a description. The base URL will be really what you are defining right now in the source. Can you see well at the back of the good enough? Okay, perfect. So the base URL I will put like logpoint.com. And then you have a lot of different parameters. So the request timeout, after how many seconds we consider that the request timed out. The retry after, so if there is a timeout, how many seconds the fetcher is waiting after retrying. The fetch interval, so this is how like if I put 5, every 5 minutes, the SIEM will query the data source to fetch the logs. Be careful with that, with the fetch interval, because for some data sources, they can blacklist you if you are too aggressive with the fetch interval. Like for example, with Microsoft 365, for example, we had issues with customers being blacklisted temporarily blacklisted by Microsoft by being too aggressive with their requests. The chart set, the processing policy. So this is usual Logpoint stuff, how the logs will be parsed, normalized, etc. I will talk about it because there is something to know with the current version of the universal fetcher. Basically, you have to select the underscore Logpoint processing policy, or the logs won't get normalized. So it's a pretty important thing to know. It will be fixed, of course, in the next release, but for now, you have to use the underscore Logpoint policy, or the logs won't be normalized. And then, I would say the most important stuff is authorization type, so how you authenticate on this endpoint, and we do support, on this source, sorry, and we do support multiple authentication mechanisms. So of course, no authentication. We also support basic authentication. So it's a pretty old way to authenticate. It will add, it will do a base 64 encoding of the username and the password that you put here. We support digest. It's basically the same thing, except it will do an MD5. You just configure what's expected by the source here. We have API key. So if you select API key, you can of course configure it here, and also configure the prefix that will be appended to the API key, depending on, once again, what's expected from the source. And finally, the authorization type or authentication method we see the most. This is OAuth. And OAuth, you have additional parameters to configure here. A dedicated URL to fetch the token. To authenticate, you need to have a client ID and a client secret, because we do support only the client credential grant type. Most of the time, this stuff, you configure it in your data source. You create an API key pair, and client ID is the public information, and client secret, of course, it's the secret information. When the fetcher will get the token, it will send this token with each request to fetch data afterwards. And depending, once again, on your data source, the token will be sent with a prefix here. So of course you can modify it. And for client authentication, we support two ways. Either the client ID and client secret are sent as HTTP headers in the request, in the post request, or they are sent in the body of the HTTP request. So it's going to depend on once again, on the data source. You can specify additional key value pairs that will be sent in the body of the request, and also additional headers. The goal, it looks pretty complicated, but the idea is to be really flexible, to be able to adapt this configuration to any kind of source. I would advise you to keep this box ticked to enforce certificate verification. And of course, you can tick the enable proxy so that the SIM is going through a proxy to do its job. This is the first step. So here I will just do no auth and disable enable proxy to see the next step. Here, we've configured the source, and now that we have a source, so here it's fixed now, the logpoint.com, this is what I just entered, and then now you can configure your different endpoints, like /v1 and logs, add a description, specify the HTTP method that you need to use, is it a GET request, is it a POST request, and depending on what you choose, if I choose POST, for example, of course, I can also specify specific key value pairs that will be added to the query. So I will go with GET request. You can add custom headers, You can add custom query parameters that will be added to the URL. And then you have really important the increment value or checksum. This is the field that is returned by your source so that the SIM can keep track of the latest data collected to avoid duplicate events. And then to make sure, I have to select something here, number, and then to make sure that the SIM will not fetch all the logs every time it queries the endpoints, you need to specify what we call the logs filtering parameters. Most of the time it's a date, like start date, for example. And here, during the initial fetch, I can select today. So the first time the fetcher will run, it will get all the logs from today. And then afterwards, it will remember the last time it ran and only fetch the delta between the last fetch. Once again, this is really specific to the source. And finally, pagination, because for some sources, when you run a query, the results are paginated. If you have thousands of results, instead of having only one response with all the results, you might have pages with 100 results per page. And if the results are paginated, you have to enter the key, pagination key here, which is basically the name of the field inside the results that contains the link to the next page, so that the fetcher will fetch the first page of result and then go over all the pages until there is no more data to collect. You can test it, of course, from here. I won't do it because it's a fake configuration, so it won't work. And then you click Submit. And here we have the name of our source. And if you want to see all the endpoints that have been configured, you can just click on here on the icon. And you see all the endpoints. And if there have been a successful fetch or failed one, you will see it here. And if there is an error, you will also be able to check here. So this is how it works. To be a bit more practical, I prepared some screenshots for two sources, actual sources. So these are configurations that work. Like for example, for Sophos Central, it's using OAuth 2.0. You have to enter these specific values. Of course, you have to replace the client ID and client secret with your own API keys. You need a specific here key value pair to be sent in the OAuth post request. And regarding the endpoints, for Sophos Central, if you are interested, well, most of the time you will be interested in the events from Sophos Central itself. So you have to configure a specific header with your tenant ID that you can find on your administration console. And the checksum and the logs filtering parameters. So here the checksum is an epoch time. It's a timestamp. And if you do that, and if you are a Sophos Central customer, of course, the logs are collected into the SIM, and 90% of the time it's going to be JSON formatted logs. And we'll see in a few minutes how to normalize these logs, of course. So when you use the REST API fetcher, you have some default fields that are added to the normalized logs. The device name is always a REST API fetcher, and the collection call type is also REST API fetcher. And there is the API endpoint here with, of course, the endpoint path. For Sentinel-1, it's pretty similar, I would say, except it's not using OAuth for authentication, but it's using an API key here. And the endpoint, well, the endpoint will depend on what exactly you want to collect. Here I'm fetching the threats threats events, so not the raw logs, only alerts, kind of alerts. So you will get the slide afterwards to have, if you are a Sentinel-1 customer or Sophos Central. And so when you've done that, so you have data inside your SIEM. But as you can see, by default, it's just raw data, so it's JSON data. And well, the point of collecting data in the SIEM is to do something with it. And we'll see how to properly normalize these logs in a few seconds. Few additional details. Each source configured in the REST API fetcher will use one license node. A known issue, to normalize the logs coming from the REST API fetcher, for now you have to use the _logpoint processing policy. So it means that you have to edit it, to edit the _logpoint also normalization policy with the normalizers that we are going to see afterwards. And for troubleshooting purposes, in the interface you have access to an error message, but to have additional details, in-depth details, everything is logged internally by Logpoint in the _logpoint repository, and the source name is this one with wildcards. Version 2 is coming with the 7.2, and it will be, I would say, more intuitive to configure. We'll bring pre-configured packages, so you don't have to take photographs of screenshots. And it's going to support custom authentication, because we try to be as flexible as possible. In the UI, but here it's going to be improved. So with the universal REST API fetcher, we have the data, and now we will see how to use the universal normalizer, which is another application, to properly normalize these logs. But first, we take just a step back. What's normalization? So when we talk about normalization at Logpoint, we talk about three different things. Field extraction, so actually extracting fields from the raw logs. Logpoint taxonomy compliance, so to make sure that the fields that we extract are compliant with the field names that we expect. Like, for example, the Logpoint taxonomy, we have the user field, so it's not username, it's not user account, it's user. And the third point is labels. So as I'm sure you know, you can add labels to the logs to describe what each log is about. As an example, as you can see here, so this is an internal Logpoint log, firewall log. Field extraction, the result is happening here. So we've extracted some fields like the source IP address, as you can see here in the log, it's called SRC. But to make it compliant with the Logpoint taxonomy, we renamed it to source_address. And same for different fields here. And then we've added labels so that someone that is not an expert in the internal Logpoint logs can understand what is this log about. So it's firewall logs, and the connection has been denied. So this is normalization. So now how we do it in Logpoint, we have different ways to do it. The first way is if you have what we call unstructured data or key value pairs, you can use normalization signatures. Of course, we provide a lot of them already as part of the product. And these normalization signatures can do field extraction, make these fields compliant with the Logpoint taxonomy, so renaming them basically. And we can apply labels with normalization signatures. But with structured data, like JSON, XML, CEF, Leaf, etc., if I take this log, this fake log here as an example, We do provide out-of-the-box compile normalizers for this kind of structured logs, but these compile normalizers are only able to do field extraction. So they will create a field called username. This one will create a field called source_IP, action, result, etc. But there is no way to rename these fields to make them compliant with the Logpoint taxonomy. Well, actually, there was no way to do it, because now, thanks to the universal normalizer, we can do, of course, field extraction, but also make everything compliant with the Logpoint taxonomy and to add labels. And it's pretty great. I don't know how you feel about it, but if you've been a Logpoint user for quite some time, it's great to finally have this kind of possibilities. And now we are going to see how it works and what you can do with it. Okay, so it's available since end of January this year. And it relies on the existing compile normalizers. I will explain more later. The links to the plugin download page and the documentation. So it builds the universal normalizer, so builds upon the existing compile normalizer. So if I take, for example, if we have JSON logs, we will be using the JSON compile normalizer. And then, thanks to the universal normalizer, you will be able to extract additional fields from what have been already extracted. You will be able to rename these fields and also to apply labels to finally have a properly normalized log. Okay, so I will go through a configuration example. So still starting with my fake JSON document here. So first, so I will try to zoom in just to make sure that it will work for you. So of course you have some fields to configure. So application name is just, well, the name of the compile normalizers that will be created by this configuration. Because when you create a new configuration inside the universal normalizer, it will create a dedicated compile normalizer that you will be able to use inside your normalization policies. So this is the name, actually the application name. The norm ID is a field that is added to every log normalized. Log identifier regex, it's, well, here I didn't put a regex, but it's a way to match the raw log so that the universal normalizer can apply the rest of the configuration. So here you have to put something that's always in the logs. So because if it matches, then it will run all the configuration on this log. And device category is a drop-down list where you have firewalls, authentication server, etc., proxy. But the most important stuff here is to select the right format. So once again, it's about structured logs. So here it's a JSON document. So I selected JSON, which means that we will be using the out-of-the-box JSON compile normalizer to do the first pass, the first work on the logs. And then, which means that with the JSON compile normalizer, you will have this kind of result here. So just field extraction, username, source, src, IP, action, result, etc. So the next step here, what I wanted to do is to extract the username without the @logpoint.com. And of course you can do that, and also extract a new field called the domain. Oops. So how can we do that? So here we have two ways of doing it. If we want to apply field extraction on existing fields that has been extracted through the JSON compile normalizer, you can either use regex. This is what I did here. If I can find my pointer. Regex or norm. In Logpoint, you can use both. So here, I put up username because I want to extract all the values of the field username, and well, it's a regex in the second column to extract a field called user. So everything until the @ sign, and then afterwards I will extract a field called domain. And the third column is to provide an example to test it if you click here. So to check if your regex is actually working. So with this, I have two new fields. So I still have username that will be extracted, but I will have two new fields. I will have user and domain. And these fields are also Logpoint compliant because they are part of the Logpoint taxonomy. And then here we have a problem with the source_IP. This is not compliant with the Logpoint taxonomy because we expect to have the source_address field names for this kind of information. So here, inside the taxonomy fields section, you can just enter the previous value and the new value of the field to rename it. So all the SRC IP field will be renamed to source_address, and you can also specify the type of the field, like if it's an IP address, a string, a number, etc. So with that, I have nearly the same log, except now it's compliant with the Logpoint taxonomy. And finally, to add labels, you can use, well, you have to use here, sorry, my zooming skills need some improvement. You can use the label fields section. And here you have to specify the name of the fields you want to rely on to decide what kind of labels you want to apply. So here I want to use the value of the action field and the value of the result field. And if action equals login and result equals success, then I want to apply the labels login and successful. Previously, here you cannot change the vendor field and the Logpoint field, but here you have to. You have to tell Logpoint what fields you want to use to apply labels. And with that, I have my whole log that is being normalized with the proper field names and with the labels. So in the end, what happened? We have the raw log, we normalized it, and this is what it looks like in the Logpoint search interface. And it's, of course, way better than what we've seen previously with just the JSON compile normalizer. And you can do it with JSON, with CSV, with XML, with Ceph, with Leaf, and also key value pairs. But key value pairs can also be normalized using normalization signatures, so you don't have to go through this universal normalizer. You can do it, but it's your call, basically. Time for questions.
I have a simple question. So
oh, yeah, but I don't think we need the microphone. I will repeat the question.
Thank you. I already tried to get the data, the threads out of Sentinel-1, and what I've seen is this is a very complex object. So in Sentinel-1, this is structured information where we have information about the client at the runtime, when was the detection, the just current user, and then a list of the interfaces, IP addresses. It's a table inside the JSON, and then finally the list of mitigations, which mitigations were successful, what were the names of the mitigations which were tried, which were successful. It's a very complex object, and I had to bite my teeth out at that point. So because how do you make that to a flat information?
Oh,
like
okay.
syslog, a key value table.
It's a really, really good question. So yeah, the main challenge with JSON documents is when you have lists, because we will create fields with indexes, like _0, _1, depending on the number of. Sorry?
And then afterwards you could rename them.
Yeah, but yeah, we could rename them, but it's not really feasible. So right now, the limitation of the universal normalizer is it's not really able to handle JSON documents with lists, because you cannot you could rename, but then you have a really huge configuration file for all possibilities. And if your lists have, I don't know, hundreds of items, it's going to be really difficult to do it with the universal normalizer. So that's a really good question, because
That sounds like a good compromise for it.
so yeah, it's more like a workaround for now than a proper solution. So for now, if you have really complex objects, JSON objects, it's support tickets to have a proper dedicated compile normalizer built by Logpoint for this use case. So yeah, universal normalizer is a huge step forward, but it has still some limitation, especially if in your case. Thank you for the question. Any other question? No? All right, so I hope it was useful, and I wish you a good end of thinking, and happy to, if you have any questions, then feel free to reach out. I will still be here afterwards. Thank you very much.